Now, the ISBNCheck program, I've given you some code. The code is basically right, but there's a bunch of small errors in there, and the comments are basically are right, I think. And so and I also gave you a handout with the formula. And the way I think to approach this problem is to translate the formula into pseudocode, and then that pseudocode you can then use for going through the assembler. So the pseudocode is kind of a pretend high-level implementation. So the way that formula worked, it was 10 times the leftmost digit plus 9 times the next digit plus whatever, plus finally 1 times the last digit, and then they took result mod 11. They divided. Okay? So what does that look like in pseudocode? Well, you've done things like this. You're adding up a bunch of things. You're adding up 10 times the first digit, 9 times whatever. So you need a variable to hold the sum. So, and you start out sum equals 0, and then you have a loop, and then you add stuff into it. So that's the first part of our pseudocode code. We know we have to loop 10 times. And the first digit is number 10, and the next digit is number 9, like that. So this is a loop that counts down from 10 to 1. Inside the loop, we grab the ith digit, where the 10th digit is the leftmost digit, but we'll get to that. We know that we can convert an ASCII digit to a number, because remember it starts out as ASCII, and we can convert it to a number. You'll remember from the other labs that, for instance, the ASCII 0 was equal to 0x30. Okay, ASCII 1 was 0x31, like that. ASCII 9 is 0x39. So if I AND that with the 0f, I get only the rightmost 4 bits, which is what I want. Now there's also the possibility of having a capital X. So the capital X represents a 10, and you're going to have to put an if statement in there to check for that. Okay, but ignoring that for the moment, we'll just take that number and convert the digit and convert it to a numerical value. I'll then multiply that by the digit position, so it's 10 times the first digit, the numerical value of the first digit, 9 times the second digit, like that. And I add that into the sum. And then I just have to count down and go back to the top of the loop. So this is the main loop of the program, is accumulating that sum. Okay? And then, of course, when I get done, I need to divide by 11 and look at the remainder. So if you remember, the way I introduced registers is I said registers are where your temporary variables are when you're an assembler. So A here, the variable A, that's going to be in the EAX register. The digit position is going to be in the ECX register. The sum will be in the EBX register. And P is an address for accessing the array. We're going to see in a moment because we're going to need that. Okay, that's going to be in another register. But, okay. So the next thing when we're converting this from pseudocode to assembler is to notice that we don't really have this array here. All right. So I mean, we could, but we sort of don't, because we would need to go from left to right, and I needs to count from 10 down to 1. So what we're going to do is we're going to have a variable called P, and P is going to be the address of the leftmost character in the array. And then as I is counting down, this loop is the same. If I have the address of the character, I can easily get it into, load it. That's easy. And then near the bottom of the loop, I add 1 to the address. I go to the next address in memory to get the next character. So we've done that a bunch of times. So this is your basic pseudocode, okay? So of course P is going to be in a register also. And then when we get done, we're going to say, the quotient equals A over 11, right? So I'll have to divide it by 11, and then, if remainder 0, that's going to be put OK. All right, put Y. Okay, otherwise I guess that was N, I'm sorry. So you'll put those in the output like that. So after this loop, you'll do that little computation. And of course, inside of the loop, it's an if statement. A is not equal to a capital X. Then we want to do this thing, right? And then else. Okay? So if it's equal to a capital X, you want to make it 10. Otherwise, you'll decode the digit. So this then becomes the pseudocode. So your job is keeping this pseudocode in mind, all right? The comments on the code are right. The instructions are wrong. Fix up the instructions to do this. All right? Thank you.